Hey guys, this is yet another quick tips episode of SmackTalk RC. We've only done one in 3 years, but we're going to start getting into this quick tips episodes more often. And this time around, we're going to be talking about the SAB Goblin, brand new helicopter about to be released into the market. So let's go ahead and check it out. So here we go. We're going to be talking about the SAB Goblin. This helicopter was the idea of the guys at SAB. If you're not familiar with SAB, you have been literally living under a rock. SAB has been making blades, rotor blades, for many, many years. And this helicopter is probably been in the works for the last year and a half, I think. Maybe even more than that. They've been actually doing a lot of work to design this thing and make it sort of unique. And the goal of SAB was to create a helicopter that was like unlike anything else out there. Initially, they're going to release this helicopter in green color, but eventually they're going to have a blue as well as a orange color. Right now, worldwide, every single pre-production batch is sold out. I believe if you want to get one, you have to wait till March or April to get one, I believe. I'm not 100% sure. But we'll talk about that here in a minute. The price of the kit is $1,000, I believe $999 in the United States. Of course, the prices might vary depending on what part of the world you're in. And the kit will come with main rotor blades as well as tail blades, both of them. So it's a pretty good value if you think about it. It's really not all that expensive when you compare it to helicopters that it's trying to compete against. A lot of cool stuff about this helicopter. The designer out of SAB, Enrico is his name. He went out of his way to do some really cool stuff with it, and we'll talk about that. More information on their website is www.goblin-helicopter.com. I believe you can pre-order from their website. I'm not 100% sure. If you're in the United States of America, helidirect.com is the exclusive retailer / distributor. They're going to take care of taking pre-orders. But great helicopter. So we're going to talk about a lot of stuff about the Goblin. We're going to talk about its features, what's so unique about it, what can you expect when you buy one. We're going to talk about the maintenance, how easy it is to build, the cost of repairs, and I'm going to give you some tips on the setup that you can expect to run on this thing. And then finally, we're going to wrap it up with a little bit of a flight demonstration. So let's go ahead and move on to our next segment. All right, here we go. I have a blue one and a green one here. And like I was saying, this helicopter is going to ship with main blades as well as tail blades, and it's also going to come with a nice painted canopy, as you can see here. The canopy color, of course, matches the boom color, and like I said before, they're going to have a green one, a blue one, and an orange one. And I'm not sure that this is going to happen, but I have made the suggestion for SAB to eventually have a black boom so that you guys can have your custom paint jobs, or you can eventually go to any canopy painters such as Canamod and order this completely different sort of paint scheme and use a black boom and match it with any canopy you want to run. But let's talk about the features. Like I said, it comes with a really nice painted canopy, painted tail boom, and the blades are also made to match the color. As you can see here, the green blades for the green Goblin and the blue blades for the blue Goblin. This blue Goblin doesn't have the blue blades. It's running just the standard SAB blades, but it comes with blue blades, and the orange will come with orange blades. So anyway, let's talk about the features. The first thing here that is sort of kind of in a way unique, even though this has been done before, but it hasn't really ever made has never been successful is the powertrain. I don't know if you guys watched episode 21. Bobby and I were talking about powertrains. The Goblin uses a two-stage gear system. Basically, you have your main gear right here, and I've had questions from people asking me if this thing is made out of metal. No, it's not. It's plastic. It's POM, which is the standard material used for all main gears on helicopters. It goes to a steel pinion. It's slanted, so it's very quiet. It's pretty wide, so it's got a lot of engagement, and it makes it also run smoother. And from there, it goes down to a pulley. This pulley right here is driven by a belt that goes down to the motor. Motor, of course, is another pulley. So it has, like we discussed in, again, episode 21, it has its advantages and its disadvantages. Disadvantages is just that it's got a little bit more parts because of that. Another disadvantage is that sometimes if you don't adjust your motor belt correctly, if you run it too tight, then you create a little bit of drag. However, the advantages are great. Number one, it's easier to set up a mesh because there's really no mesh to set up. You just tighten your motor belt and you're good to go. Another advantage is the fact that the Goblin is capable of running a multitude of different motor kV ranges, anything from 3 to 400 kV all the way up to about 1000 kV, because when you multiply one gear ratio times the other, you have that flexibility. So that's a cool feature. The powertrain on the Goblin is just something kind of unique in the sense that even though it has been done before by a couple other manufacturers, nobody's really doing it right now, and it seems to be it seems like the Goblin is going to make this powertrain system very successful. Another cool feature of the Goblin is the pitch links, and this was already done by Compass Models, and SAB incorporated this into their design many months ago. The purpose is the same. The way that SAB designed it is a little bit different. SAB has pretty much 2 bolts running into here and 2 separate bearings. So it's just, even though it achieves the same result, it's a slightly different design. But basically, as you can see here, this is actually pretty cool, because now when you're going to set up your pitch, all you have to do is you just remove your bow link right here. Let's see if I can get an angle here to do this. You remove your bow link. Oh, it's too tight that way. And then, as you can see here, this is threaded, so you can loosen this up or tighten it. And if you loosen it up, you're actually adding pitch, negative pitch. If you tighten it, you're removing it. So it's pretty cool. Makes, tracking the helicopter a breeze. As you can see here up on top of the blade grips, you have these little markings that show you where 0 pitch is. So you don't have to kind of, mess around with trying to figure out with a pitch gauge where your pitch is. You just basically line up these slots and you're good to go. These little lines, I'm sorry. So that's a pretty cool feature about the head. Moving down from the head, another cool feature is the fact that, as you can see, you have 3 very, very short servo rods. The servos are so close to the top of the helicopter that you really don't need bell cranks. The geometry, the way the servos are placed, is near perfect. I mean, you basically have like virtually no interaction going on into your flabberless system. You just build these 3 rods the exact same length. They're pretty short, by the way, and that's it. You're good to go. There's only 3 servo rods in this entire helicopter. Done. So pretty simple there. And then another cool feature about this machine is that if you actually look at it, everything is like right here. This is your helicopter. You got motor, your powertrain, your servos, of course your powertrain, and then you have all your electronics here, and then you move up and you have your swash and your head, and that's it. This is your helicopter, this little piece right here. And as you can see, it's all made out of CNC aluminum, and it's pretty strong. It's really hard to break this part of the helicopter because it's all very compact and very well put together. Main shaft is very hard to bend because it's, number one, it's 12 millimeters. Number two, look at how long it is, like sticking out of the top bearing block. Like you only have like couple 2-3 inches sticking out, so you need a lot of leverage to bend that main shaft. It takes a lot of effort to bend it. The spindle right here is a 10 millimeter spindle, and it's got 2 radial bearings as well as the thrust bearings, of course. So it's a pretty standard setup when it comes to that. But going back to this right here, as you can see, again, this is your helicopter. So the side frames are literally just there, just supporting your battery and doing nothing else. So like you're flying this part of the machine and everything else is kind of going along for the ride. So as we move to the back of the helicopter, So let me take the green one. The green one is the most desired goblin, because goblins are supposed to be green. So as you move back to the boom area, the whole boom is made out of carbon fiber. It's solid carbon fiber. Well, not solid, but it's a, I guess, strong piece of carbon fiber. It's very, very strong. You know, a lot of people ask, how strong is that boom? It's very strong. Like if you could be here and try to flex this thing, you wouldn't. It's really, really strong boom. It's very big inside too. And by being big inside, you can run a tail belt without having to run multiple pulleys. In other words, the belt can actually ride freely inside this boom. And also, because the boom is so big and the inside diameter of the boom is so big, you can also get away with running very big pulleys. These pulleys are actually 3 times, 4 times bigger than any other pulley I've ever seen on a helicopter that has a belt-driven tail. Same with the front pulley. It's also a very big pulley. And other than that, the only other pulley that you have on this helicopter for the tail belt is a idler pulley, which is right here. And all this does is this tells you where your belt tension is. That's really all it does. You really don't even need to run it. If you don't want it, you can just get rid of it. But it's really cool because as you start tightening the belt tension, this tells you exactly where your tail belt tension needs to be. The boom is attached to the helicopter with 2 nylon bolts, as you can see here. And what that does is, it's supposed to do is when you have a crash, the nylon bolts will break and the boom will detach from the helicopter, therefore saving itself. I've crashed this green Goblin 3 times. I've yet to break the boom. As you can see, the boom has scratches everywhere. It's been, again, it's been crashed 3 times. Of course, I'm sure that if you guys crash this thing very, very hard and crash it with tail first or out of a tail slide or in any other orientation where you're going boom first, you might break the boom, well, of course. But for most crashes, if they're relatively mild or if you're not hitting the boom, you're not going to break it. It's literally going to break the nylon bolts and it's going to detach from the helicopter. So those are, I believe, the main features of the Goblin. I mean, it's got a lot of really cool stuff to offer. The tail gear ratio is pretty high. And by being so high, it allows the helicopter, and I'm really not going to go and elaborate into the tail gear ratio because that's subject to change still to this day. But by having a very high tail gear ratio, you can get away with running this thing at very low head speeds and still have pretty good tail authority. Let's talk a little bit about the maintenance sort of and the build of this helicopter. This is so far the easiest helicopter I've ever built. It just literally takes no time. If I were to be given a box kit in kit form right now, I could literally put this kit together in about 1 hour and 15 minutes. I'm not saying ready to fly, I'm not saying the servos would be in or the motor, but the actual bare bone kit, I could have it done from the box to ready in about 1 hour and 15 minutes. That's how simple it is. Basically, you have this big plate right here, the CNC plate. And then from this CNC plate, you have another plate up top that holds your servos. And they're attached with these posts right here. Once you put these together, the next step is just to take the motor and mount it onto the motor mount right here. And once you have the motor and the motor mount slides in. It clamps right here with these 2 bolts. And then it tightens with these 2 bolts right here. So that kind of builds your whole base of the helicopter. At that point, you put your servos in, you stick your main shaft with your main gear, and you secure it with a how do you call that?
Bolt?
No, a collar, I'm sorry. You secure it with a collar. The collar has a Jesus bolt and it locks in place. And then moving on from there, you put your motor belt, you put your 2 pulleys here, the pulley for the motor, the pulley for the tail. You tighten your motor, not mesh, but your belt tension for the motor. And that pretty much builds the core of the helicopter. That process takes about 20 minutes, maybe 30 at the most. And once you have that done, you're almost really done with the machine, because like I said before, everything else is just going along for the ride. Then you install your side frames. And as you can see here, you have 1, 2, 3, 4, 5, 6, that doesn't count because that's boom, 5, 6, 7, 8, 9, 10, 11, 12 bolts. Side frame goes in. You do the same on the other side. Now you have your side frames. You put your battery tray at the bottom, and then you mount your landing gear. And I didn't talk about the landing gear before, but the landing gear just couldn't be any simpler. You have these, first you have this landing gear mount in the front that extends into another CNC plate that holds your speed controller. And then you have a very simple landing gear mount right here in the back. And the landing gear itself, it's obviously two sides. So if you crash on one side, you know, other models, for example the Whiplash, offer the same convenience. If you crash on the left side, for example, you break the left landing gear, you don't have to replace both. They're completely independent from each other. Then after you're done with that assembly, you know, you might be an hour into it, you take your boom, and don't pay attention to this crack around here. This is just a prototype boom. The final product is not going to look like that. It's obviously going to be a much better finish. But as you're done with that, you take your boom, and the boom comes ready to go. Basically what you do is you take your boom, and the boom comes with these little plastic inserts that go in on the sides. It comes with the hole for the servo. You put those plastic inserts, and the plastic inserts are threaded. At that point, you put your servo, and you secure your servo with your screws, your bolts, into the threaded plastic, and the servo is ready to go. Then this guide right here that holds the boom, the push rod, slides into the boom, goes right into the boom through a hole that's already in there. You don't have to drill or do anything. And this piece is threaded on the other side. So you put these two bolts in here, tighten them up. At that point, you have your servo and your tail push rod in place. And then you move on to the tail section. And for the tail, what you do is you have these two plates. One plate includes your vertical fin, and the other plate right here, both of them clamp onto the boom with 4 bolts, 2 on this side and 2 on the other side. Then you build, of course, you put your tail outpush shaft with your pulley for the belt. You make sure you put your belt in, then you assemble all the stuff, put your tail blades, put your pitch arm and everything else, and you're done. At that point, you take the boom and you put it into the frame. Like I explained before, you hold the boom into the frame with 2 nylon bolts. You can see them very well from here. If cameraman follows the boom to the front, you can see the 2 nylon bolts right here. You tighten them up, and then at the bottom, the boom just basically goes into these slots on each side, and you tighten these nuts right here, and that's it. That puts the boom on the helicopter. Finally, after you engage the tail belt into the tail pulley, what you do is the bolts that I showed you before that hold these plates, these 2 bolts on this side and the other side, you loosen them up and you move this back and forth to adjust your tail belt tension. You retighten them and you're good to go. So very, very easy, very minimalistic helicopter. It really doesn't take a whole lot to build it or to fix it, just very few parts. I get some questions every once in a while from people about what is this? Well, for all of you guys familiar with electric static discharge, this sort of kind of helps prevent glitches due to ESD. And I don't think it's needed on this helicopter, but as a general rule of thumb, if you're a Spectrum or a JR pilot that is flying DSM-2 or even DSM-X technology, and you fly in cold climates or in climates that are typically dry where there's ESD in the atmosphere, you definitely want to make sure that you ground your helicopter if you're running a helicopter with a tail belt. If you fly Futaba or some of the other brands, I believe they're not as susceptible to ESD, but as a good precautionary measure, I still run it on any helicopter that I own that runs the tail belt. Okay, so if you're like me and you're flying a helicopter, you want to make sure, or buying a helicopter, you want to make sure that you can afford the freaking helicopter. I usually don't look at the actual price of the helicopter as much as I look at the parts of the cost of the parts, because let's face it, anybody can afford $1,000 or $50, even $2,000 one time. But if you're going to have to spend $1,000 every time you crash, you're definitely not going to want to look into a helicopter that is that expensive to maintain. So the cost of repairs on the Goblin is actually pretty attractive, to tell you the truth. You know, I remember when I first saw this helicopter several months ago, I was kind of like thinking at the back of my head was like, wow, like this thing looks cool, but like it must be really expensive to repair. And I was actually very surprised when SAB when SAB released their parts prices, because they're actually pretty attractive. They're very competitive with any other helicopter out on the market. So as I was explaining before, when you crash this thing, what are you going to break? Well, it depends on how you crash it. If you crash it really, really hard on the head, you might break very little actually if you crash it hard on the head, because again, it's a very strong 10 mil spindle, it's a very strong 12 millimeter shaft, and all this area is just so beefy and just so short that it's pretty hard to do a lot of damage in this area. So if you crash on the head, maybe you'll bend your main shaft, maybe you'll bend your spindle, probably you screw up your bearings inside the hob and stuff like that, you'll break your blades. But as you move down, you might not break anything in this area. Now, if you crash in landing gear first, depending on how hard the crash is, you might end up breaking your frames. In this helicopter, you're more prone to break frames than, say, on a T-Rex 700, just because of the way it's designed. However, the good news is the frames are very inexpensive. One side frame for the Goblin is $40. $40 for this. This is cheaper than a side frame for like a T-Rex. Even much cheaper than that. If you go to the goblin-helicopter.com, which is the website I showed you earlier, you can see all the parts prices. They have them all posted already on their website. And as you start browsing around, you look at the prices. Yeah, of course, some of the CNC aluminum things are expensive. But for example, here's the side frame, as you can see, is $40. Showing out of stock, of course, because parts are not available yet. But $40 for a side frame is pretty inexpensive. So another thing that is cool about this machine, and this really has nothing much to do with the cost of repairs, but like I was talking before, it's so simple. If you crash and you break your side frames, you literally remove the 12 bolts. I think I mentioned 12 bolts, and you just literally put your new side frame, put your bolts back in. The only thing you have to remove is like the motor wires here, the satellite antenna, in my case here, and then you can make the swap. Unlike other helicopters where you have all this stuff, like the servos are going through the frames, and you gotta like loosen up the servos, and you have the servo lead going in through the frame, and it's such a pain in the butt to change frames. Or helicopters, they have bell cranks, and now you gotta remove the bell crank and the servo and the this and the that. With this, you remove those bolts, put your new frame, put the new bolts, you're good to go. So it's actually really, really simple to repair. Another question I get about cost of repairs is the price of the boom. As you can see here on the Goblin-Helicopter website, a boom is $70. So that seems like a steep price. Yes, it does. But think about this. This helicopter has no torque tube. This helicopter has no front tail case, where you have like a front tail case holding your boom and your gears and all that. You don't have any of that. You don't have a horizontal stabilizing sort of horizontal fin. You don't have a clamp for that fin, or a clamp for the tail boom, for the boom supports. You don't have boom supports themselves. So when you think about it, $70 covers the entire tail. And that, coupled with the fact that you might not break the boom on every crash, makes cost of repairs very attractive on this helicopter. So of course, there's certain parts that are extremely expensive, like this special mount for the servos. It's a very intricate, very well machined piece of CNC aluminum that is just very complicated and very difficult and time consuming to make. So that part is very expensive. I don't see how you could ever break that part, in my opinion. I mean, I've seen crazy stuff. Maybe you can break it, but I don't think I could break it. But of course, if you break a part like that, yes, you're talking a lot more money for more intricate, more complicated parts. But what I call the disposable parts are actually pretty inexpensive to repair. Landing gear, I haven't checked the price, but I can check it right now for you guys if you're interested. Or you can go to the website, again, goblin-helicopter.com, and check the prices. But the landing gear you can just buy individually, I believe, so you don't have to buy both sides if you don't need to. You can just buy one and use it on each side as you please. So I guess that covers it for cost of repairs for the Goblin. Alright guys, I'm going to give you a couple of recommendations here for the electronics that you want to run in your Goblin. As you guys know, I'm a JR guy. I fly Horizon products. So I'm really not very well familiarized with some of the other servos that are out on the market. I personally run the JR 8717 HV servos, but I understand if you don't want to run those, they're like $240 servos, I believe. Any good servo that has proper centering, that is fast enough, that has good torque, will work very well in this helicopter. I know Futaba makes a new servo that runs at high voltage that is excellent. I know Outrage is making the torque servos. They run really well. So there's a lot of good servos out there. MKS makes a servo. Savox makes a servo. Just find a good servo that has a good powertrain, I guess, within it. Good, metal gears preferably. I would recommend metal gears just because you have this direct connect system, so you want something that is strong, good torque. Servo horns, I'm running some carbon fiber. They're really not carbon fiber, they're plastic, but they have some carbon in them, so they're pretty strong. I don't recommend running just a cheap El Cheapo sort of horn for the servo. You want to make sure that horn does not strip very easily. These have a high content of carbon again, so they're pretty strong. So that's for servos. As for motor, I've been flying the Scorpion limited edition 4525 motor. It's a 520 kV motor. The Goblin is going to ship with a 22 tooth pinion or pulley, I guess you could call, for the motor. And with the 22 tooth pinion, you get a 9.7 to 1 gear ratio, which if you're running a motor that it's in the range of 500 to 540 kV, you're going to be able to run about 2200 or so on the head, 2250 on the head without a problem. Of course, a lot of other different gear ratios or pulleys or pinions will be available from the SAB guys, so that you can run a separate motor, a different type of motor. But I recommend something in the range of 500 to 540 kV for the motor. And then of course for the speed controller, I recommend you watch our episode number 21 where we talk about speed controllers. But I basically have two Goblins right now. As you saw before, I have one with the Castle. This one's got the Castle 160 HV. It's the ICE 2 version, and the other Goblin that I have has the Scorpion 130 amp Commander version 5. They're both excellent controllers. You can't go wrong with either or even one of the Contronic controllers. So that covers it for that. And then of course, flabberless system. This is the question that I get all the time. What flabberless system should I run? It really depends. I personally prefer that you run a flabberless system that has a sensor that is separate from the unit. Just because of the only drawback of this helicopter that I've seen thus far is the fact that it just doesn't have a lot of room for electronics. So if you look up here, this is about all the room you have to put all your electronics. So you definitely want to have some sort of a flabberless system that allows you to customize the installation. If you have a B-Stex or if you have a mini V-Bar or one of those controllers that have the sensor built into the actual controller itself, you are going to have a little bit of a hard time installing it. If you have a controller that has a sensor that is separate, like the CGY750 from Futaba or the full-size V-Bar, then you can mount the sensor in the bottom plate, which is what I do right here. I don't know if cameramen can see the sensor, but the sensor is upside down, stocked away, doesn't mess, doesn't interfere with anything. It's kind of unconventional way to set it up, but it actually works well. And this Goblin right here has over 200 plus flights. And as long as you make sure you use the proper tape and everything else, you should be good to go. So that does it for flabberless system. The Goblin is going to have right here, if Mr. Cameraman can zoom in there, this plate mounts right up here. And basically, if you have a flabberless control unit that has the sensor built into the unit itself, and you have to plug in servo wires or leads into that unit, of course you can't put it in the bottom plate like I show you. So what you do is you install this in here in place of that, and then you put your electronics under this, and then on top of this you put your flabberless control unit, like a mini V-Bar, or like a B-Stex, or like a Skookum. I believe the Skookum is the same way, or any of those. But again, I personally recommend, once again, flabberless unit has a separate sensor. It gives you a lot of flexibility when it comes to installing this stuff. Last, for the electronics section here is the BEC. You can have a battery and mount it right down here, or you can have a BEC, battery eliminating circuit. And then once again, episode 21, we talked briefly about BECs. This is the Western Robotics Super Hercules BECs, mounted right here. So I have a long sort of lead running all the way to the front to hook up to the battery. I think that covers the electronics. I got speed controller, motor, got servos, flabberless system, BEC. So that about does it. So Yeah, one last thing, the tail servo. What you do is you mount the tail servo, you use an extension, like a servo extension. You run it from your receiver or from your flabberless control unit down in the middle of the, like inside the frame. Run it down this way, and you leave it kind of loose in the sense that if the boom ever separates from the helicopter in a crash, you don't tear up a lead, it just detaches, it just separates from the extension. And that's been the case with me. 3 crashes so far, the servo has not gotten hurt. So you want to make sure that you have a servo extension once again connecting your tail servo, so that again, if you crash and the boom comes out, that the servo extension unplugs itself. If you run the tail servo wire all the way straight up to your receiver and you crash, you're going to break that wire. You definitely want to kind of save your servo leads. I believe that covers it for electronics and recommended setup. All right, now that I've showed you pretty much everything you need to know about the Goblin, we're going to take it for a ride. I know there's a lot of videos on YouTube and all over the place, but I'm just going to give you my, I don't know, my impressions, my thoughts on this thing as I fly it. And we're going to fly it with very, very low head speed and very, very fast head speed. So let's go ahead and go to the field. We're going to Torches, the Orlando Remote Control Helicopter Society. And here we are at the world famous Torches field in Orlando, Florida. I have my blue Goblin today, and we're just going to go ahead and take it for a quick flight. This first head speed that I have here is only 1700. Some of you guys might think, wow, 1700, that's like pretty low. Yes, it is. It's very, very low. And like I said before, you've seen a lot of videos with the Goblin everywhere online. Tarek flying it, me flying it, Orlando helicopter blowout, demo, crashes, all kinds of stuff. But you've never actually seen the Goblin fly at low head speed, I don't think. So I'm just gonna like fly for like a minute or so and show you. As you can hear this thing, it sounds like it's just going to quit. It's pretty low head speed right now. But the beauty of it is the tail gear ratio allows you to do that, which is really cool. So you can see I'm doing all kinds of sideways stuff, and the tail is just holding really well. Let's just try like a normal funnel. So if you want to practice, you know, like basic stuff, maneuvers that don't require a lot of power and that don't require a lot of heart stopping, you know, changes in direction and stuff, you know, this head speed is great. You might have a little bit of a head wobble if your dampening is too tight with this head speed. As you can see, I really don't have it at 1700, which is really cool. So I found that sweet spot in my dampening where, you know, it's not too loose and it's not too tight. So that's it for the low head speed. Now, when you want to really crank this thing up, all you got to do is just bump your idle up. And this is about 2280, almost 23. Now, look at the stopping power of this thing. It's awesome. So the cool thing about this helicopter is how versatile it is, in the sense that it flies slow, it flies fast, it flies smooth, it does smack. It can do also like sort of like FAI type. I guess I couldn't call it FAI because FAI does not allow flabberless, but you know what I mean. It does. It could do also like very smooth, sort of like precision flying maneuvers and stuff. So let's do a fast, really fast, like pulling ass, like fast forward pass right here. See how fast it can go out of a dive. So you can see that thing is well over 100 miles an hour, 160 kilometers an hour for sure, for sure. So, and as you can see, it's relatively quiet. I mean, the blades are loud, but the transmission is very quiet and very smooth. Let's wrap it up with like zero flipping, reversal climbing into an auto. Just do like a really fast, like holding ass auto here. Right in front of the cameraman. I'm proud of him. He didn't walk away. So that's it for the flying features of the SAB Goblin. Thank you for watching this quick tips. This was quick tips number 2, where we talked about the SAB Goblin. We have a lot of different quick tips coming up. We're going to try to put out one quick tips every month. I believe next month we're going to be talking about the all famous miniature aircraft Whiplash. If you have any questions, like I said, the website is goblin-helicopter.com. You can go in there, you can look at the parts prices, you can look at the dealers. So if you're interested in buying a Goblin or whatever, you can see who is the distributor, who is the dealer. Just click on the dealer's link and stuff like that. And you know, there's a lot of resources. I think there's a forum for this on haleyfreak.com. I think there's a forum on runrider.com. Those are the 2 US-based most popular forums, but I'm sure overseas in the UK and Australia and everywhere else you can find a lot of resources in their local forums over there as well. So thanks for watching, and see you guys next month.